Good evening, everyone. I welcome you all to the live session number 12 for week 12 for the course Non-Conventional Energy Resources. The course instructor is Professor Pratap Haridosar from IIT Madras, and I am this course TA, Amit Kumar Sharma. So, as you already know that we are covering the previous week's uh, course content, and we are solving some sample problems every week on Monday 6 to 8. So let's start with the week 12 course content. So it is supercapacitor.
ওইটাই বলছে তুমি যেটা বলছো বলবে
Anyone who is online, please mute your mic. Okay. So let's start with the supercapacitors. So in this, we will cover what is a supercapacitor and how does it differ from a capacitor, and what type of applications is it suited for it, and what type of materials are used for supercapacitors. So basically, a capacitor is a two-terminal passive electronic component that stores charges in the form of electric field between its metal plates. It is made up of two metal plates, which is electrode as anode and cathode, and these are separated by an insulator known as dielectric. So this is the basic of a capacitor. So when source voltage is applied across the two terminal of a capacitor, the current want to flow through the insulating material, but it opposes the flow of electrons. So when the voltage across the capacitor terminal is equal to the applied voltage, the insulation medium still resists to the flow of electrons. This resist phenomena make a change which create an effect to store energy in the form of electrostatically field. So these are the working principle and basic of the capacitor. You can see the diagram here. So we are having metal electrodes and one dielectric. So the dielectric is filled between the metal electrodes. Okay. And in supercapacitor, it is also known as supercap, double layer capacitor, and ultra capacitor. The electrode of supercapacitor is coated with active carbon as electrode material. This is a major difference that instead of like in capacitor there were no such coatings, but in supercapacitor it's these are having coating of active carbon as electrode material. A separator is used between anode and cathode in supercapacitor, whereas a dielectric material are used in conventional capacitor. So this is another difference, that here we are using a separator instead of dielectric material. The supercapacitor stores charge either using electrostatic double layer capacitance, also called EDLC, electrostatic double layer capacitance, or electrochemical pseudo capacitance, or both known as hybrid capacitance. Okay. So supercapacitors are made of metal foils or electrode, each layered with activated carbon. These foils sandwich the separator in between. You can see here in the diagram. These are electrode, both sides. Then the active carbon layers are there, and one separator is there. The separator is a ion permeable membrane. So important, it is ion permeable membrane, such as graphene, used in modern capacitor. So as a graphene is a material for the separator, which is used in modern supercapacitors, which provides the insulation and exchange of ions of the electrolyte between the electrodes. So it provides the insulation for the electron, and it's Like it ensures the exchange of ions of the electrolyte between the electrodes. This is a major change for supercapacitor, that we are using activated carbon layers on electrodes. We are using a separator. Okay. And in capacitor we were using dielectric and only the electrodes. So these are some advantages of supercapacitors, like they are having high capacitance, high energy density, lower voltage, high cycle life, charge and discharge much faster than batteries, and bridge the gap between capacitors and rechargeable batteries. So these are the areas where the supercapacitors are having importance. Supercapacitors are widely used in regenerative braking, like in when we apply the braking in electric cars. So as you know, the braking, the wheels are moving at a very fast RPM, and suddenly we are stopping them. So in that process, so much of heat is generating. So we can develop a system so that that energy can be used and can be stored in batteries. Okay, so there are different types of mechanism available by which we can store the energy in regenerative braking. Loading and unloading activities, start and stop of electric vehicles. So these are the major areas where the supercapacitors are used. Now, what is the major difference between supercapacitor, battery, and capacitor? The supercapacitor is having electrical energy and it uses ions. Okay, so it generates electrical energy and it uses ions. Battery, it's depend on chemical energy and also uses ions. And the capacitor, it's operate on electrical energy and use electrons. So the major difference between capacitor and supercapacitor is that the supercapacitor is using ion and the capacitor is using electrons. So this is a capacitor. You can see this is the positive side electrode, negative side electrode. There's a dielectric material. In this material, you can see the positive side electrode surface is having negative ions, negative potential, and the negative side electrode is having positive potential this side. So this is the complete surface. You can see which are taking part in the electricity generation. But instead, but in on the other side in supercapacitor, the electrode materials are in the form of particles. So you can see in this the electrode material was complete solid, like only a one, like you can say the one object, or you can say the complete one assembly, or like this. But in the supercapacitor, the electrode material is in the form of small particles. So you can see the small particles are there. In between, there are some spaces in which electrolyte is present. Okay, so these are the on the end side. These are the positive side and negative side. These are the current collectors. This is the separator material. Okay, so basically from the diagram you can see the supercapacitor is having more surface area for the electrode. Okay, you can see the every small particle is having a surface area.
Sorry to interrupt, sir.
Yes,
But I can't able to see the screen. The screen is blank on my phone. Is there any diagram on screen, sir?
1 minute. Is it now blank or from the previous slides is it blank?
From previous slide, sir.
Okay, just wait for some network connection. Maybe at your end, some network connection issue is there. Anyone else is facing issue? Anyone else?
Mm, I don't think so.
Mr. Jayaprakash? Dr. Binoy, are you having any issue in the presentation? Are you able to see the screen or not? Please confirm.
Now, yeah, now coming, but initially it was gone.
Okay, okay.
Yeah.
Maybe there was some network issue.
In my side.
Yeah, yeah.
Not. I was also unable to see you. So network
Okay.
issue maybe from your side also.
Yeah, I think so. Is it now visible or not?
Yeah, right now visible.
I'm
Okay,
not
okay.
able to see, sir.
Maybe if they are able to, Mr. Jayaprakash is able to see,
Okay.
then I think the network issue is
I
in
will I
on
will
your side.
restart the meeting, sir.
Just log
Yeah.
in and log out. Other candidates are requested to log out and log in again. They will be able to
Okay.
see.
Sure, sir.
Yeah, please try that. Yeah. Okay, if you are if anyone else having any issue, please let me know. So basically,
Sir,
you can. Yeah,
sir, may
please.
I ask a question? Means issue means some question regarding the assignment. May I ask you?
Actually, assignment question we are not supposed to discuss. We will solve some sample assignment question in this class. Maybe those questions will help you to solve the assignment question. We are.
No. Sir, actually, assignment that already has been solved and submitted. Only I have the doubt. The charge discharge rate, which one is faster for in comparison to the capacitor and supercapacitor?
Charge and discharge rate.
Right, sir.
Okay. I think we will take this question at the end of the class because otherwise it will disturb the class. Okay, so at the
Sure.
end of this class,
Sure,
we will discuss this.
Sure, sir. Sure, sir. Okay.
Okay. So in supercapacitor, you can see the electrode material are in form of the particles. So the total surface area has been increased. Okay, and the electrolyte is filled in between them. So now there are more area and they are having more interaction, so they can store more energy as compared to the capacitor. So this is a diagram which is showing the specific power watt per kg to specific energy watt hour per kg. So you can see the batteries, supercapacitor and capacitor. So batteries are having high specific energy. So they are having high specific energy. So watt hour per kg is very high, but they are having less specific power watt per kg. Okay, and the capacitors are having very low specific energy rate, and they are having high specific power, and the supercapacitor are in between them. So basically, supercapacitor is filling the gap between the batteries and the capacitor. So we can get a decent specific energy with decent specific power. So these are charge and discharge duration. So capacitors are having charge to discharge duration like millisecond to microseconds. Okay, and the supercapacitors are having charge to discharge duration like seconds to minutes, and batteries are having hours. Okay, so these are the charge or discharge durations, because these durations are depending on this specific energy. Okay, watt hour per kg. As you can see, the capacitors are having very less specific energy, so the charge discharge time is very less as compared to the batteries and as compared to the supercapacitors. Now cycle life. So capacitors are having infinite cycle lives, you can say, and supercapacitors are also having near a million life cycle, which is also very huge, and batteries are having 1,000 life cycle. Normally in laptop batteries, we are having life cycles of around 800 to 1,000 life cycle in laptop batteries. So these are the material which are used like for electrode, activated carbon, graphene, and carbon nanotubes. Activated carbon, it's a natural carbon and polymers heat treated in inert atmosphere. Okay. And graphene can restack. Actually, when you're using graphene, then it can be restacked to the graphite. So you have to look into that also. In carbon nanotubes, it's a cylindrical surface is used. For the electrolyte material, we are having aqueous electrolyte, organic electrolyte, and ionic liquids. For the aqueous electrolyte, voltage is restricted to 1.23 volt, and for organic electrolyte, a lower conductivity is there, and that is propylene carbonate. And for ionic liquid, organic salt with no solvent and melting point below 100 degree. So basically, the supercapacitors bridge the gap between the capacitor and batteries, as we recall from the energy specific and energy diagram. High surface area carbon metals used in electrodes, because we are using particles instead of a complete electrode in supercapacitors. Aqueous, organic, as well as ionic liquid considered as electrolytes. So we can use the aqueous, organic, and ionic liquids as electrolytes. So these were about the supercapacitors. Now come to the flywheels. So in this we will learn about what is a flywheel and describe how a flywheel operates and mention the limits of flywheel operation and indicate materials aspect associated with the flywheels. So basically flywheel is a mechanical energy storage device. So it's a mechanical energy storage device. Point to be noted, mechanical energy storage device. In this we are not talking about electrical energy, not talking about any electrochemical or anything. So just now we are completely from supercapacitor, we are completely coming into the mechanical part. So it's a mechanical energy storage device. Energy stored by increasing RPM of a rotating wheel. So it is the principle of operation, like energy stored by increasing the RPM of rotating wheel. Energy extracted from the wheel as needed, which slows the wheel down. Okay. So flywheel is very beneficial for smoothing of the power output of an energy source. It extends the ability of an energy source to operate outside of its rating by storing its energy and releasing it as needed. So it can store energy and it can release when the energy is needed in the system. It can be used for regenerative braking. So these are the major points of flywheel. Like it can smooth off the power output of an energy source. Okay, extend the ability of the energy source to operate outside of its rating by storing its energy and releasing it as needed, and regenerative braking. So these are some examples. First is foot operated swing machine. So this is swing machine. You can see the diagram. There is a one wheel. There's a larger wheel. So this is the machine. This is the pedal. So the operator will push the pedal up and down, and so the wheel is attached with some mechanism. So this will rotate with the belt drive. The motion is transferred to this wheel, and this wheel is attached with the machine. So in that way, the machine works, and there is a, you can say, a needle. So this needle moves up and down. Okay. So this is the working of the swing machine. So in this, the operator only push the pedal only once. Okay, for one rotation, but the second rotation is automatically happened. Okay, that is done by the flywheel. That flywheel store the energy in first push and releasing the energy for the second push. So this is the example of swing machine. second one is toys. Just 1 minute. So we have seen number of toys in our childhood, and you can see now also. So some toys are not having any batteries or any electrical connections, but still, if you give some if you give some power to them, like if you rub the lower tires on the floor just for like 2-3 rotation, then they can store that energy, and when you release the toy, that that toy can go for some distance after releasing. Okay, so when you're pushing the toy backwards or when you're pushing the toy forwards and you're not releasing the toy, so basically when you are pushing or rubbing the toy against the surface, so in that time, in that time, the rear wheels are rotating and they are having connection with the flywheel. So this rotation of the rear wheels is giving energy to the flywheel, and flywheel is storing that energy. So when you release the toy, that stored energy is again coming to the rear wheels and the toy is moving forward. Okay, so this is the diagram. You can see the flywheel is connected with a smaller gear, and that gear is again connected to a larger gear, and this with this gear. Okay, and this is the complete diagram. So this is the outer wheel that is connected with this gear. So when the outer wheel rotates, this gear rotates. This gear give power to the, suppose this is gear number 1. So gear number 1 is connected to the gear number 2. This gear number 2 is connected with the gear number 3, and gear number 3 is connected with the gear number 4. Okay, so your rear wheel is connected with the gear number 1, and the flywheel is connected with the gear number 4. So the rotation of the rotation of the wheel give the RPM to the gear 1, and that RPM is transmitted to the flywheel through gear 2, 3, and 4. So you can see the gear number 1 is larger as compared to the gear 2. So maybe based on the design or gear ratio, you can see the gear 2 is smaller than gear 1. So suppose if gear 1 is taking 1 RPM, then maybe the gear 2 is having 5 to 6 RPM. Okay, so when the gear 2 is connected directly with the gear 3, so that RPM is transferred to the gear 3, and gear 3 is connected to the gear 4. So in this way, the flywheel is getting the energy, and the flywheel can store the energy, and that can also be released when you release the toy. So this is the arrangement. The third example is the reciprocating engine. Okay, so we are having a flywheel. So this is a very common example, like in our two-wheelers, in our four-wheelers. Okay, in any IC engine device, this mechanism is used. So energy stored during the power stroke is used for the next intake stroke. So basically, I think you have covered in your BTech that we are having normally 4-stroke engine. So the first stroke is intake. And the second stroke is compression. Third stroke is power stroke, and the fourth is exhaust. Okay, so in the power stroke, when the fuel is combusted with the air, so they release high amount of energy. So that energy push the piston downwards. And when the piston is pushing downwards, that flywheel is storing the energy. So when the piston is at the downside, so that stored flywheel energy is again given to the piston. The piston again move upwards. Okay. So in this way, the flywheel works. So when again the piston moves upward, the flywheel stores some energy, and again piston moves downward. And in this way, the cycle is run. Okay. So the energy stored during the power stroke is used for the next intake stroke. So this is the example of flywheel used in reciprocating engine. So we can also use the flywheel in regenerative braking. Okay. So this is the wheel. This is a brake pedal. When you can connect a battery to it, so that battery can store the energy. When you push the pedal, that energy is stored in the battery. And what is the mechanism? So yeah, this is the mechanism. Okay. So there are some gears connected to your brake pedal. Okay. So these are the configuration. So in this, with the movement of gear, as we have already seen in the example of toys, so in similar fashion, in this system also, the energy will be stored in the flywheel. Okay. So what is the formula for energy stored in the flywheel? So it is E equals to half I omega square. It's very important. So I is the moment of inertia, omega is the angular velocity. So the energy stored increases only linearly with the mass, but with square of the angular velocity. So you can see from this formula that E is proportional to omega square. So if you increase the angular velocity, then the energy stored will be increased in the square manner. Like if the omega is become 2 omega, then E become 4 times. Okay. So if you if you double the angular velocity, then your stored energy will become 4 times. But the connection with the mass is linearly. Okay, because I is the moment of inertia and it is in the form of mr square. Okay, so I is connected with the m. If you increase the mass, that linearly depend on the energy. Okay, so for a solid cylinder, I is half mr square. So if you double the mass, like m become 2m, then the energy stored will become twice. So it's linearly depending with the mass, but with the square of angular velocity. So this formula is very important. It can be used for numericals. Okay. So with the specific energy and specific power, so we can see the flywheel is coming between the batteries and supercapacitor. Okay. The flywheel is coming between the batteries and supercapacitor. It is having moderate specific energy with moderate specific power. So supercapacitor were filling gap between the batteries and capacitor, and now flywheel is filling the gap between batteries and supercapacitors. So these are the material with the kilojoule per kg. Like if you are using lead flywheel, then it can store 1 kilojoule per kg. Cast iron can store up to 25 kilojoule per kg, and carbon fiber reinforced polymer can store up to 150 kilojoule per kg. So it's very high. And the carbon fiber reinforced polymer can go up to 60,000 RPM. So it's a huge RPM. So in conclusion, the flywheel store energy using a rotating wheel. The energy stored increase as the square of the angular velocity and only linearly with the moment of inertia. So that is an important point. Try to remember this. The energy stored increases as the square of the angular velocity and only linearly with the moment of inertia. The high angular velocities attained can result in the material disintegrating due to the force involved. If you are having a very high angular velocity, then there will be stresses also, and that can result material disintegration. Okay. Mechanical properties of material are therefore critical in enabling high energy storage in flywheel. So due to the force involved during high angular velocities, stress will be there. So the mechanical properties are become important. So whenever you want to select a flywheel for a particular system, then you have to identify the maximum angular velocity that system can attain. Based on that, you have to select the proper material so that at particular or at highest angular velocity, there will be no stress that can uh, disintegrate the material of the flywheel. Okay. So mechanical properties of the material are therefore critical in enabling higher energy storage in flywheel. Now the magneto-hydrodynamic power generation. So in this, we will cover the operating principle of magneto-hydrodynamic power generation, indicate the different modes in which it can be implemented, and it indicate a challenge posed by this technology. So if you are having flow of hot gases, okay, you can say this is the pathway. So gases are flowing in between this. So we can develop a system. So we can use this high temperature hot gases to generate electricity. So this can basically this system is used in thermal power plants where hot gases are there. Okay, the efficiency for this power plant is limited by the Carnot efficiency, which is 1 minus T2 upon T1. So T2 is the lower temperature and T1 is the higher temperature. So in combined cycle power plant, we are having hot gases, and on the topping cycle we can put MHD. MHD is short form of this magneto-hydrodynamic power generation. Magneto-hydrodynamic MHD. And in the bottoming cycle, we are having thermal plant. Okay. So for combined cycle power plant, we are having hot gases. Then in the topping cycle, we are having MHD. And for bottoming cycle, we are having thermal plant. So the important point is plasma. So plasma is fourth state of matter. Okay. These are the ionized gases which can be generated at very high temperature. And in this, the low ionization energy elements can be used. So to generate the plasma, we use low ionization energy elements so that they can become ionized with energy with low energy as compared to the higher ionization energy elements. Cesium and potassium have relatively low ionization energy, so we are using cesium and potassium for this MHD. So these hot gases are flowing. They're putting cesium and potassium in between, and so when the hot gases are flowing, so the plasma will be generated here, and the electrons and ion deflected in opposite direction and generate voltage. So these are the electrodes. Okay, so this will create a electrical circuit and we will get the voltage. So you can see here, cesium and potassium are added to the gas. The temperature should be high enough to ionize these gases, and it is called seeding. And the electrodes are connected with the load. We are having hot gases, we are doing the seeding, adding of cesium and potassium for ionization, and we are having MHD topping cycle and thermoplasma is a bottoming cycle. So movement of the electrons and ion will depend on the charge as well as mass. Okay. So these are some systems like in periodic generator. We're having single electrode with connect with the load. In segment Faraday generator, we are having segment of electrodes. Okay. And in the whole generator, we are directly short circuiting these and connecting the first and end terminals directly. So these are different configuration: periodic, segment Faraday, and whole generator. So basically, magneto-hydrodynamic power generation enables generation of power from hot gases without moving parts. So as we have seen that there are no moving parts, we are only having hot gases flow, and we are generating plasma and we are getting the electricity. It requires high temperature, because if you want to generate plasma, then you require very high temperature. Usually combined with a regular thermal plant, but appears at the top end of the stream. So we can install this with combined cycle power plant as a topping cycle. It can have toxic implication based on implementation strategy. So if you want to implement, you have to consider all aspect, because due to the gases, plasma, it can be toxic implications. Okay. This is about the magneto-hydrodynamic power generation. So as you all know that this is week 12 and this is the last week of our class. So this is the course summary. So these are the topics in every week we have covered. Like we have covered the use of energy around the world, nation per capita and by sector, and what is the impact of energy uses on the environment, like CO2 emissions we have seen. Okay, like approx 500 exajoules energy was needed per year. Okay, and around, I think the CO2 emission is more than 420 ppm, is very large as compared to last 200-300 years. Okay, we also covered solar energy. So I think solar radiation can deliver this complete 500 exajoule in 1 hour. So we are having huge scope for this energy. Okay, we have covered various aspects like solar thermal, solar PV. Okay, wind energy we have covered. We can generate the energy from wind. We have also covered bed's limit. We have covered OTEC. We have covered geothermal, biomass. Biomass is quite important, which is having like biogas generation. So biogas generation is quite useful nowadays because because the India is trying to replace the use of natural gas with the compressed biogas. Or you can say CBG. So it is quite important topic. You can generate the CBG from biogas because the raw biogas is having around approximate 60/40 ratio. 60% CH4 and 40% CO2. So there are number of upgradation technology available like water scrubbing, pressure swing adsorption. Okay, so from those technology, you can upgrade the biogas to more than 90% of CH4. And so that upgraded biogas is called CBG. That CBG can be used as a fuel in CNG vehicles. Okay, you don't need any separate kit, any separate system. Directly you can fill the CBG to the any CNG vehicle. So as of now, with recent data, government of India is importing 50% of natural gas, and we are trying to half this import. Okay, so we are trying to increase the energy mix of CBG in our primary energy supply. So that is the role of biomass from agricultural residue. We can generate biofuels like biodiesel, methanol that can be blended with the petrol and diesel. So biomass is a very good renewable source which are having a number of applications. We have covered batteries, we have covered fuel cells, and fuel cells are also quite important. In summary, the most of research are focused toward the low temperature and high temperature fuel cell. So the one is PEM fuel cell, polymer electrolyte membrane fuel cell, and second one is solid oxide fuel cell. So this PEM fuel cell is low temperature fuel cell that can be operated around 670 to 80 degree, and this SOFC require high temperature around 800 degree centigrade. So they both are having different operating temperature and different mechanism, but also they're having their respective applications area. Like SOFC can be very useful for stationary power generation, and SOFC are very useful for power plants or any company, any industry where the exhaust heat is freely available. Okay, so we can use the exhaust heat to raise the temperature of the system, and we can generate the electricity. And then PEM fuel cell, you require pure hydrogen. PEM fuel cell require pure hydrogen. On the other side, SOFC, you can introduce hydrocarbon also. Okay, because it's operate on high temperature, so it can do the internal reforming. Okay, so you can fuel SOFC with natural gas, hydrocarbon, biogas, etc. But there are still limitation because you have to remove the sulfur and siloxanes. Okay, siloxanes and sulfur are very harmful to the electrodes. Okay, or specifically the anode, because you are supplying the fuel at anode side. So the siloxanes and the sulfur can damage the anode. So the damaging of anode will hamper the triple phase boundary, and that will directly hamper the electrochemical reaction, and that will decrease the efficiency. So these are some important point about SOFC. Now come to supercapacitors we have covered, flywheels we have covered, and magnetohydrodynamic power generation we have covered. Now let's come to the questions. Okay, so the first question is, batteries and supercapacitors are identical in performance characteristics. True or false? So the question is, batteries and supercapacitors, are they identical in performance characteristics? Take 2-3 minutes to answer.
बस बता देना क्या क्या है।
Okay. Just wait for 1 more minute.
पाकिस्तान
So the question, yeah, okay. So the question is, like, batteries and supercapacitor are identical in performance characteristics. So it's false, because we have seen in our slides that batteries are having very high specific energy capacity as compared to the supercapacitors. Supercapacitors are having medium specific energy capacity, but having medium power capacity also, opposite to the batteries. So it is false. The second one is, we have given a statement like, the use of regenerative braking in electric vehicle is based on. So the use of regenerative braking in electric vehicles, we are having options. Take 2-3 minutes. Go through all options, because it is not mentioned that only one option is correct. Okay, maybe more than one options are correct. Try to recall the slides we have discussed and try to recall the class material. The question is about regenerative braking. So what type of system is used in regenerative braking? Try to recall that and try to check all the options. So I think you will be able to answer. Anyone? Okay. So the first option is brake pads are removed after each day and attached to the battery for electricity generation. So I think everyone can eliminate this option because we cannot remove the brake pad each day. And if we attach it to the battery, then there is no means to generate electricity. So this is wrong. The braking action rotates the rotor of a generator in the car. Yeah, because when you are applying the braking, so there are some gears we have seen. So braking action rotates the rotor of a generator in the car. So those gears are connected to a
Yes.
generator that can generate the electricity. So yes, this option is correct. Braking generating heat during operation, this heat is converted to electricity. So actually, yeah,
No.
we know that braking generates heat, but we know that this heat cannot be converted to electricity directly. So to overcome this issue, we have only come up with the option of regenerative braking. So we don't want to dissipate the energy in the form of heat. Okay. So this
Yes,
heat
yes.
is not converted to electricity. Okay. So we want to eliminate this actually. So that's why the regenerative braking comes into the picture. Now the rechargeable batteries in the car are able to accept electricity generated in the car. So yes. So we are having batteries, rechargeable batteries in the car, so that can accept the electricity from the generator and they can recharge. So the option,
This is linked to the
yeah,
regenerative brake.
these are linked. Okay. So the option B and D are correct. So the correct options are braking action rotates the rotor of a generator in the car and rechargeable batteries in the car are able to accept electricity generated in the car. Let's come to the question number 3. A person is going from Chennai to Pondicherry in a car of 2000 kg, which is moving with an average speed of 60 km per hour. What will be the approximate amount of energy recovered due to regenerative braking? If it comes to a full halt and 50% of the energy is recovered during the braking process. It's a numerical. So for hint, you can use the energy formula of half mv square. Now try to solve this numerical, take 2-3 minutes. Hint for this question is
Sharma sir, are we given a calculator?
calculator. I think you have to check the guidelines. Actually, I am not aware of the complete guideline for the exam. But now you can use for this our class. You can use, no issue.
Sir, actually, I know that the calculator from the online means from the computer that is permissible, but separate hardware that is not permissible in the examination.
Okay. Okay. Thank you for sharing.
Ra, 6,000.
Try to follow the units. Actually, the speed is given in kilometer per hour. Okay. So first convert this speed into meter per second. I think I have given you so much of hint. Try to solve the
225 kilojoules, half, 50%.
2 to 5.
Two 275 kilojoules.
275 kilojoule. Okay, is it the exact answer or are you having something round figure data?
सब्जी लेने चलना सोमवार है
Are you having the exact answer or are you having just answer nearest to it?
I think it is something nearest to it. 16.67. 16.
What is the exact answer you are getting? What is the exact value you are getting? Please tell me.
277.
You are getting 277 kilojoule.
Ah.
Okay. Have you considered this 50% also?
50% of the energy required during the making process. Yeah, 50% I have not considered. 1 minute.
Okay.
So then 50% of this, so 150. No, but that is not the option. Oh.
Yeah. So basically, actually, if you solve this question, then if you apply this formula, so first of all, you have to put the mass 2000, then you have to put the velocity in meter per second. So 60 into 1000 on 3600 to square half. So after solving, you will get, what is the value?
16.67.
It will come around 6 upon 3600 square to 1000. So you will get 2777.77. So basically
27.
277.7 kilojoule. Okay. But now if we have to consider this also, if it comes to full halt and 50% of the energy is recovered during the braking process, we have to multiply with 0.5. Then it will come to 138 kilojoule, but that is not the option. So we have to consider this as the answer, and the nearest value to this is 275 kilojoule. So the correct answer will be 275 kilojoule. But now please, anyone is able to tell me that why we have to put the speed in meter per second? Why we cannot put directly in kilometer per hour? Anyone?
Is coming in joules.
Or you have to just do the unit balance, then I think you can answer. Try to do the unit balance. What is the reason for that? What is
Are
the
we going? Is there any other formula linked to this? Because it should be the same option. The answer should be the correct option. That's what is my doubt.
actually I was thinking that also actually because based on the calculation, I think this formula is we can use, but I think we can forward this question to the further NPTEL higher team. So maybe they can look into the option. So you can mail them actually.
But this question is not available.
Okay, I will mail them, and I will upload the answer on the updated slides. Okay, I will mail them,
Please.
and the slides will be updated. In the slide, I will solve the question, and if the answer is like 277, then I will put that also. So now let's come to the point. What is the reason that we have to put the speed in meter per second? What is the reason? Just a very basic unit balance. If anyone aware, you can share. What is the reason for that?
See, SI unit, na? SI unit, you have to use meter per second for velocity.
Oh,
And
okay, SI unit, but the energies are coming in joule. Okay.
Yes, SI
So you are
unit, the unit of energy is joule itself.
okay. So how the meter? So it's a mass is in kg.
Yeah.
So it is in meter per second square. So how is it converting into joule? Actually, my question is that you are putting kg, you are putting meter per second square, and how is converting to joule? Just very basic. This question just
Joule is the energy of the unit. Joule is watt per second. Watt is
so what is the unit of joule? Joule is a unit of energy, but we can also
Sir, may I answer, sir?
yeah, please.
Sir, energy means, sir, force into displacement from the unit point of view, and
Okay.
force is mf. The means mass into acceleration. Acceleration
Okay.
means, sir, acceleration means length divided by time square
Okay.
into distance. So then
Okay.
finally we are getting that unit of this joule.
Okay, right. Actually, joule is the Newton into meter. Okay.
Right?
So this
Yes.
Newton is the force. So in Newton, we can also put it like kg meter per second square. Okay. Like he said, mass into acceleration ma. Okay, so this mass is kg, acceleration meter per second square. So now see here, it will become kg meter per second square into meter. So this will become Newton. This is meter. So Newton into meter is joule. Okay. So in this way, it is joule. So whenever you are solving any numerical, always try to familiar with the units. Okay. If you know the units very well, then you can solve the question very easily. I think it's clear.
Sir, can you clarify one question
Yeah, please.
about the exam? This exam will be of 2 hours or 3 hours?
Actually, I'm not aware of the exam schemes actually. We are
Sir,
only
I have read this instruction. It is for 3 hours only.
3 hours.
Okay.
And then it will be of what type?
Hall ticket is uploaded on the system. You can see the duration, everything is written there. Please
Yeah, I
go.
think you can check your admit card, and on the admit card everything will be mentioned.
Yeah,
I think
yeah,
that
everything is clear.
Okay.
yeah, yeah.
Son, watch
Okay, I
time,
understand.
to report, everything's there.
Yeah, okay, okay.
Yeah,
And
okay.
I didn't get the card, I will check it.
Yeah, please check your email.
Email, yeah.
Okay, boss.
So the
Sir,
correct
may
answer
I
is
place a doubt now?
yeah, please.
Sir, the question in the assignment, it was regarding the capacitor. Means which one is fast charging, capacitor or as the supercharger?
So what is the due date
Supercapacitor.
for this assignment? Is it over yet?
No, sir, it is submitted and I am getting that it is wrong. But
So
it's
what is
not
the
clear
due date?
why it is wrong.
What is the due date for assignment actually? I'm asking that.
No, sir,
Last
due date has been
19.
over.
19.
So
No. The due date has been over and it is answered that it is wrong. Just
okay,
I am
due date has been over, na? Due date has been
yes,
over.
yes,
Okay.
over and I have got the answer also. But I have the
Okay.
doubt regarding that answer.
Okay, let me go to the slide. I think this will address your doubt.
Capacitor and supercharger, charger. Out of that, which one is fast charging?
Okay. So
Supercapacitor.
you can see the charge discharge duration.
Yes, sir.
So you can see the seconds to minute is having supercapacitor and millisecond to microsecond for capacitor. So this
Right.
capacitor is charging in millisecond or microsecond and also discharging in millisecond and microsecond. So
Yes.
the faster charging will be for capacitors.
Right, sir. I have given the same option, but
Okay.
it is coming wrong, and that's why I'm asking. As I'm
As
just reading out the question, sir. Please listen.
yeah.
Charge and discharge process occurs faster in a dash than a dash. Here, my answer was faster in a capacitor than a supercapacitor.
Okay.
But it is mentioning that the answer is wrong. The right answer is faster in a super capacitor than a capacitor. It was question 3, assignment 12.
Maybe I think you have to raise the query to NPTEL team. Maybe there is NPTEL nodal team also. So please raise the query to them. So maybe they will be able to answer because as of the slides, and I think the capacitor is having millisecond to microsecond for charge discharge duration, and the
Sure, sir.
supercapacitor is having seconds to minute, and batteries are hours.
Right, sir.
So maybe I'm not having the question exactly and what are the options. So maybe you can ask the NPTEL team, you can forward your query. So maybe they will revert back to you
Sure, sir. Sure, sir.
with the correct explanation. Okay. Maybe I am not
Right.
aware of this in more detail. Maybe they can give you more correct answer to that.
Right, sir. Right, sir.
So let's come to the question number 4. So what are the major replacement done in a conventional capacitor to convert into supercapacitor? So what are the major replacements done in a conventional capacitor to convert into supercapacitor? Try to recall our first few slides.
Sir, may I answer, sir?
Yeah, please.
Sir, electrons by ions,
Okay.
and the third option, static charge in induction by the dynamic motion of the charge carriers.
Okay.
So these two, as per my consideration, sir.
Okay. Try to go through other options also. Try to recall that in
One
capacitor
more.
yeah, please.
Last one is also correct.
Yeah, right. Because in the capacitor we were using only a flat surface. On the other
Flat
side, in the supercapacitor we are using particles. So the total surface area was increased.
It's increased, yes.
Yeah.
Got it, sir. Right, sir. Got it.
I think you can think about option 2 also.
Option 2 is also correct. That's what I was thinking.
Yeah, right. So
Sir, like, how is it like you give all the 4 options correct, and if I don't mark option 2, and I mark only if you will not give, you will cut
I think you will get partial marks,
0.25
I think.
marks.
Yeah.
Equally, I think.
Yeah.
Because we have seen the evaluation. It is like this only, that you have to mark all the 4.
Yeah, right.
Electrons by ion, dielectric block by electrolyte. सर ऑप्शन 2 के बारे में थोड़ा सा बताएंगे?
Yeah, dielectric block by electrolyte. So as we can see from our slides. Yeah. So in this we were using a dielectric material for capacitor. Okay. But instead of in supercapacitor we were using electrolyte. The electrolyte can be filled in between the electrode material, on the locations in between the electrode material. Okay. So basically the reaction area has been increased, so it can store more energy. Okay, so we are using electrolyte instead of dielectric material, and we are using a separator material, separating both and transferring the ions, and also doing the isolation of electrons. Okay. So the correct answers are all 4. Electrons by ions, because we are supercapacitor ions are responsible for the generation of electricity. Dielectric block by electrolyte, static charge induction by the dynamic motion of charge carriers, and the flat contact surface by non-flat contact surface. All 4 are correct. Question number 5. If two energy storage devices have distinctly different specific energies, then the device with higher specific energy has the higher specific power. The device with higher specific energy has a lower specific power. Specific energy and specific power don't necessarily have the same trend across devices. The device with higher specific energy will store more energy for the same weight. Go through all the options. Take 2-3 minutes to answer.
Sir, your option is not displaying here.
Maybe just wait for 1 minute. Maybe the network issue is there. You can wait for 1 minute. Is it visible now?
So
No,
this
sir,
I have
not
opened
still.
laptop as well mobile also. Voice is coming on mobile, but it is seeing on laptop. So better to log in through Wi-Fi or anything else. In mobile
Okay,
network.
this may be the problem. Actually, I am attending through laptop and the hotspot connection. Maybe the
Is anyone able to see the question? Anyone able to see the question?
Yeah, I'm seeing. Yeah, I'm able to see.
Okay.
Yes,
Maybe
yes, visibly clear. Yes.
yeah. Maybe the network issue is there. You can check your network connection, please.
Higher specific energy has lower power.
The last one is correct. Three are not correct. First three are not correct.
Last one is the
You
device with higher specific energy will store more energy for same weight. Okay.
Yeah,
Go through other 3 options also.
they are not necessarily true. Not like that.
Take 1 or 2 minutes more. Maybe you will able to clarify.
Okay.
Only option 2 is correct.
Sir, the third option is right.
Okay, yeah.
The specific energy and specific power don't necessarily have the same trend across the devices.
Yeah, right. Because we have seen that the trend is different for capacitor, trend is different for supercapacitors, different for battery, and different for flywheel. So yes,
Correct.
option third is correct. Option fourth, the device with high specific energy will store more energy for the same weight. That is also correct. Now, option A, the device with higher specific energy has the higher specific power. No. The device with higher specific energy has the lower specific power. No.
Huh.
So option C and option D are correct.
As per this, I have one question.
Yeah.
Like you see, batteries have higher specific energy and lower specific power. You see, capacitor, they have lower specific energy but higher specific power.
No, actually, we can not generalize the statement actually. We just can do comparison actually. If you go for the capacitor, then that is having moderate specific energy and moderate specific power. Okay, we are not talking about only batteries because flywheel is also there. So we cannot generalize the statement actually. Okay, because it's a generalized statement. The device, it means all. Your statement is this statement is valid for batteries, you can say, That battery is having high specific energy but having low specific power, but it is not valid for the supercapacitor.
Acha.
Okay, it is not valid for the capacitors. Okay, so it is not a generalized statement, because it is not mentioned only for battery, it is mentioned device. So we cannot consider this. Only option 3 and 4 are correct. Is it clear?
Is it linked to the weight? Is it linked to the weight?
Yeah, weight is linked, na? Yeah. Watts per kg, na? Okay, come to the question number 6. In general, there are 4 gears. Gears are represented by the letter G. In a simplest flywheel setup, if the size of the first gear G1 is smaller than gear G2, what will happen? So you have given a configuration in which G1 is greater than the G2. Now, if you suppose change the size of gears, now the G1 is smaller and G2 is bigger, then what will happen? Take 2-3 minutes to answer.
Sir, may I answer?
Yeah, please.
Sir, the smaller gear will move with high RPM.
No, you have to give the option, na? G2 will move, G2, which
Okay,
option
okay,
is
okay,
correct?
okay, I'm telling.
Second option.
G2 will move at lower RPM than G1. Okay. Go through other options also.
To option 4 also.
Sir, option 2.
Option 2. Okay, G2 will move at lower RPM than G1. Okay, because as we have indicated in the question that the size of gear G1 is smaller. Okay, than the size of the gear G2. So the gear G2 will be bigger. So the G2 will move at lower RPM, right? Because G1 is smaller and G2 is bigger. So bigger gear moves at lower RPM than the smaller gear. Correct? Option 2 is correct. Any other option?
Saying option 4 also. G2.
G2 will move at lower RPM than G4. Okay, G2 will move at lower RPM than G4. Okay, anyone?
G4 is linked with the flywheel.
G4 is linked with the flywheel. The G3 gear is linked with which gear?
G4.
G3, G4, I know, but how? But from where the G3 is getting power?
G2.
G2, right? Yeah, so
G2
G3
will move slow.
G3 is getting the power from G2. Now go through all the options. I think now you will be able to clearly answer.
2 is
G-
sure shot correct. Second, third, fourth,
G1 is connected
third
with
is
the
wrong.
G2. Let me give you the hint. G1 is connected with the G2. G2 is on the same shaft with the G3.
As
Okay,
G3,
so
yes.
G2 and G3 are having on same shaft. And G3 is connected with the G4. And G4 is on the same shaft with the flywheel. Now we have changed the gear. Okay, the G1 is smaller and G2 is the bigger. Now you have answered correctly one option, that G2 will move at lower RPM than G1. That is correct. Okay. Now what about other options?
Sir, option 1, G2 will move at same RPM as G1. It is not right because the number of teeth here is different, and so it is not possible that RPM will be same.
No, so it's wrong, na? So why are you saying it's correct?
I'm not saying correct, sir. I'm telling you, you are asking me what other option. I'm telling option
Okay,
1 is
okay.
wrong.
Yeah. Option 1 is wrong. Okay, correct. Option 1 is wrong. That is correct. What about option 2? G2 will move at lower RPM than G1. You are
So
all
that is
saying
answered
that
already.
is,
So that is answered already. That is
that
right
is
answer.
correct.
Right
Okay.
option.
What about the option number 3? G2 will move at higher RPM than G1. So that option is incorrect because option 2 is correct because the G2 is now bigger as compared to G1. So that is also incorrect. Now what about option 4? G2 will move at lower RPM than G4. Now what about this? This is important.
Sir, I think that is also right. The reason the option 4 is also right. The reason behind that is the gear 2 and 3 is mounted on the same shaft, which will rotate at same RPM. Now,
Yeah.
gear so as number of teeth here is high, so it will be lower in speed.
Yeah, right,
And so
right. Your sound is breaking, but yeah, you got the point. Actually, gear 2 and 3 are on same shaft, and gear 2 is also bigger, gear 3 is also bigger. Okay, so gear 4 is smaller. So G2 will move at lower RPM than G4. So correct options are G2 will move at lower RPM than G1 and G2 will move at lower RPM than G4. So correct options are B and option D. Let's come to the question number 7. Energy stored in flywheel of radius r rotating with velocity v is proportional to the space square of the angular velocity, cube of the angular velocity, square root of the angular velocity, and velocity raised to power 0. Take 2-3 minutes to answer.
Cube of the option 1 is correct.
Option 1, square of the angular velocity. Okay, let's wait for 1 more minute. If you want to give the formula, you are welcome.
Half I omega square.
Yeah, right.
Yeah.
Okay. As we know that the flywheel energy is considered as half I omega square. I is the moment of inertia and omega is the angular velocity. Okay. So the question is energy stored in the flywheel of radius r rotating with velocity v is proportional to the square of angular velocity. So you can see here E is proportional to the omega square. Okay. So anyone, if the radius is r, velocity is v, what will be the angular velocity omega?
Sir, B by R.
Sorry,
V divided by R. Omega
V
equals to V divided by R.
yeah,
R.
right. So the angular velocity is v divided by r. So this question can be tweaked. Okay. They can ask you like this also, like energy stored in flywheel of radius r rotating with velocity v is proportional to the, they are asked with you radius also. They can also ask with the velocity also, not angular velocity. They can ask you about the linear velocity. They can ask you about the radius. So you should also know that what is the formula for omega. Omega is v by r. You can put it like this: half I v by r square. So it's v square by r square. So E is proportional to 1 by r square. Okay. So it's reciprocal to square of the radius. So it can be also a question. So try to remember all the formulas. The correct answer is square of the angular velocity. Question number 8. In a combined cycle using MHD, typically option A, MHD is used as a topping cycle, MHD is used as a bottoming cycle, ionizing additives are added, ionizing components are actively scrubbed from the flow before it enters the MHD region.
Sir, option 2 is right. MSD is used as the bottoming cycle.
Okay, MHD is used as a bottoming cycle. Yeah, it seems correct. Is it so?
I'm checking, sir.
Okay, because we are having two options, topping and bottoming cycle. Try to recall the slides we have covered.
Sir, this third option is not completely clear to me. Ionizing additives are, if it is that there that cesium or potassium is
Yeah,
added,
yeah,
the additives are
right,
there,
right.
then that
Right.
third option is also right.
Yeah, right, right. Those additives are cesium and potassium. The third option is correct.
Right, sir.
What about other options?
The fourth one is not right. So only option as per me, the second and third option is right.
I think you should rethink about option second, because we have seen our slides that about this bottoming cycle and topping cycle. Yeah. So in this slide, you can see
Sorry,
first the
sir.
whole
I
case.
have missed that topping and bottoming. First one, I
Yeah.
think it was bottoming.
Then
Sorry, sir.
MHD is topping cycle and
Right,
thermal
sir.
power plant is bottoming cycle. Okay.
Sure, sir. Sure, sir.
So for question number, question number 8, the correct options are MHD is used as topping cycle and ionizing additives are added. Okay? And these additives are cesium and potassium. Question number 9, MHD based generation is typically used in association with, in which association we are using the MHD based generation?
Thermal.
Okay, let wait for 1 or 2 minutes.
Yes, sir. Thermal. As per me, also the thermal power plant.
Okay. What is the reason for that?
Sir, all the ion, sir, I'm answering, trying to answer. All the
Okay.
ion from Cesium and potassium, that the charge will be collected by the MHD, but still they have some thermal energy, and with that thermal energy, it will pass through the turbine of the thermal power plant, and it will give another means whatever in the thermal power plant turbine expansion process is there. Through that expansion, we will get another enthalpy drop will be there, and through that the power will be generated, and that will be converted to the electric energy using the generator.
Your MHD system working is correct, but your answer is wrong. My question is that why MHD is only used in thermal power plant? What is the reason behind that? There is a main reason that is mentioned in the slides also. I think mentioned in the class notes also.
Okay, sir, I'm not got it. Okay, I'm thinking, sir.
Yeah, please try to think your working principle is correct. You have told everything right, but the exact reason is not there. You're just missing the exact point.
Thermal energy partly used for ionizing the low ionizing material, which is additive. So
Yeah,
some
right,
energy
right.
is expected. Therefore, efficiency increases.
Yeah, yeah. This is the correct answer. Actually, we can use the thermal energy for ionization. Okay. And in that way, we can generate the electricity and we can increase the overall efficiency. That is the main point. Okay. So the correct option is thermal power plant. Is it clear?
Yes, sir.
Yeah. Okay. Okay. Question number 10. Match the following. 1.23 volt, atomic number 19, and the 6000 RPM. AFRP, flywheel, water, and seeding material. Take 2-3 minutes to answer.
Sir, option 4 is right.
Option 4, A2, B3, and C1. Okay. Let's wait 1 or 2 minutes more.
Sure, sir.
The question is you have to match the list 1 with list 2. So let's try to match. So the 1.23 volt. So as we have know that is linked with the water. Okay. Because if we want to break the water, we have to supply this much of voltage, 1.23 volt. A2. B is atomic number 19. It will be the seeding material. And the 6000 RPM is with the CFRP flywheel. The correct option is A2, B3, and C1. Now let's come to the end and our quiz. So first one is magneto-hydrodynamic power generation uses the plasma state of matter. Is it true or false?
True.
Yes, sir, it is true.
Yeah, because we have covered that magneto-hydrodynamic power generation uses the heat to convert the plasma, and from the plasma we can generate the electricity. So it is true. The capacitor stores energy using ions.
Sir, it is false.
Yeah, because they use electrons. False. The gas diffusion layers enable reactant from channel areas to reach land areas.
Sir, it's true.
Yeah, gas diffusion layers are used for the reactants for channel area to the land areas. True. Energy stored in flywheel increase as the cube of the angular velocity.
Sir, wrong. False.
Because I E is equals to I omega square.
Half I omega
Okay,
square.
half I omega square.
Square, right.
A flywheel has its moment of inertia tripled and its angular velocity doubled. The energy stored in it increased by a factor of. Right, calculate and give the answer.
Sir, 12 times.
Sorry,
12 times.
12 times.
12 times, right.
Okay, okay. Let's wait for 1 or 2 minutes more.
Should be 18.
I think you can check the solution. The correct answer is 12. Because the inertia is tripled, so I become 3I. The angular velocity double, so omega will become 2 omega. Now put these values in the formula half I omega square. So it will become half 3I to omega square. So it becomes 3 into 4 I omega square by 2, or 12 half I omega square. This half I omega square can be considered as old E energy. So the new energy will be 12 times of the old energy.
Yes, it's correct.
So the energy stored in it increased by a factor of 12. So this is the.
Now I have a doubt. May I place the doubt, sir?
Yeah, sure, sure.
It is about the same assignment, question number 7. It was mentioned that wheels, it is regarding the flywheel.
Okay.
Wheels with different mass and rotating at same angular velocity will generate same amount of energy.
Okay.
The question is that it was mentioned that it is right, but I think it also may not right, because depending on the radius, for the same mass, if two wheels, we are actually here it is comparing between two wheels. If between two wheels there is same mass and same angular velocity, then also if the radius is different, then it can vary also.
No, if radius is different, if the angular, they have mentioned that angular velocity is same, okay? So they have
Right.
mentioned that omega 1 equals to omega 2. Omega
Right,
1
sir.
is V1 by R1, omega 2 will
Right.
be V2 by R2.
Right, sir.
So now if you are saying that R2 is greater than R1,
Right, sir.
so for them to be equal, then this V1 and V2 will be different. But the omega 1 and equal to omega 2. So if you are changing the radius, it means you are changing the velocity, but the ratio is same. That is the point.
But sir, as per the energy equation, as you have also write, half I omega square.
Yeah.
So
So we are
if
actually
we,
we are taking the angular velocity omega.
right, sir.
Okay. If you are
Right, sir.
if your omega is same and then you are changing the radius, it means that the linear velocity is different, but the ratio is same. Okay. Like suppose you can write 10 upon 5, or you can write 4 upon 2. These both are equal, but you can see for this case 10 upon 5, the radius is 5 centimeters, suppose 5 meter, but for 4 by 2, radius is only 2 meter, but for both the omega is 2 radian per second,
Sir, that is
because
absolutely right that you are mentioning here. So in both the cases, W omega 1 and omega 2 is same. But here kinetic energy, that is equals to half I omega square, where I is the mr square. Mass is same. If mass is same, then also there is a scope that if various radius with same omega, and then it can vary, na sir?
no, they have also mentioned na, the inertia is same. Is it mentioned or not?
It is mentioned that wheels with same mass and same
Okay,
angular velocity, same mass,
okay,
but
okay,
not about radius.
okay. But because the angular velocity is same, then suppose if radius has been increased,
It's possible.
okay. No, actually, I think the radius, because in the if the omega is changing, so the radius are also changing. Okay,
Got
and
not got it, sir. Again,
yeah,
please, sir.
yeah, yeah, yeah. You are maybe. I think they have to also mention about moment of inertia instead of mass.
Right, sir. But they have mentioned the mass, not momentum inertia.
Okay, they have mentioned the mass, so that will be mr half mr square. Suppose solid disk, and v is equals to omega square, omega v square by. Okay,
Sir, in case of circular disk, so in both the equation we can express it the equation of energy, right? Like 1 by 4 m r square omega square, right, sir?
actually, I have to check the details.
Right, sir.
Yeah, yeah. But in this case, I think that if you are putting the like half I omega square we are having, okay. If you are putting the like 1 by 2 mr square, then it will become 1 by 4 m r square omega. If you put, you are given the omega na, so you have not given the radius. Okay, so that the omega you can put like v square by r square. So r square will be cancelled out. So you will left with only the linear velocity. So maybe they are comparing like that. The radius is if the because the linear velocities are changing. So I think the mass and the angular velocity is sufficient. So the radius, the impact of radius will be actually cancel out because the omega is changing. Because that omega, because if you go through the complete formula, then the radius can be cancelled. Okay, so that omega is taking care of the radius actually. I am thinking in that perspective. Maybe you can search on the Google also. I'm not sure, but I think this is the answer because omega is taking care of the radius. So with only mass and with the omega, we can compare the both flywheel energies.
Right, sir. But just my query is that, sir, why will appear this velocity, the linear velocity? Because directly we can write down here it is comparison between the angular velocity, mass, and the energy. Then we will write down the energy equation in terms of omega r and the omega r and the omega and r. That's and mass. That's only. So in that case, 1/4 m omega square r square, and omega is given here, and mass is also given. So mass omega will be directly put at there, and for different velocity, same amount of mass and omega will put there, and we will compare with different radius. So in that case, simply we are getting the difference energy. So that I am thinking, sir.
Actually, I'm not able to see the question, and maybe I'm not getting the question. So it will be great if
Okay, sir.
you can share
Okay,
the question on email. Actually, no? That will be great
okay, sir.
because when I
Yes, sir.
upload this, so you can because you are telling maybe I'm not getting the question correctly.
Right,
Okay,
sir.
okay.
Take, sir. Right, sir.
So it will be great that
Okay,
if
sir.
you can share on email
Sure, sir.
or okay, you can
Thank
also
you.
ask the NPTEL team.
Thank you, sir. Thank you.
Okay, then thank you everyone for joining the complete 12-week sessions because we have covered all 12 weeks successfully. Every week from 6 to 8, we have taken the classes. So thank you for joining every week.
Sir, before
And
thank you, may I place request to all of your team that, sir, so this type of so many, so it is about, you are discussing today 12 weeks, and then in previous weeks also, some confusing answer is there. See, if in the final examination, you teachers are considering this type of confusing answer as the right answer, sir.
actually, if you are having any doubts, actually, because for the live session, we are having some time limitation and we are also having some like regulations that we have to follow. So for your current assignment doubts, you can always put your queries on the email, or we are having a form also. So in that form, you can put your queries. Okay, because
Sure, sure, sir.
the
What I
time
mean,
is
right, sir. What? Yeah, you are absolutely right. But what I mean to say, now exam is ahead us.
yeah,
So
yeah.
there is no time to ask further you to you rather for the final preparation. So what I am asking you, so this type of confusing answer, if some confusion is there, if you teachers are considering that answer as the right answer, that only, sir.
No,
From
no.
all the participants who are all
Uh,
the candidates from all the candidates who are joining this examination,
no,
if you
actually, the
forward this
answer,
message.
the question and answer, or are all selected by the experts, and there
Yes,
are
sir.
only like particular answers for particular questions. So you have to select options very carefully. Okay,
Sure, sir.
and
And here multiple right answer is there. So
yeah, yeah,
normally
yeah,
what
yeah.
is happening, the problem is that multiple right answer. So out of
Right,
four
right, right,
answer, maybe four or one answer is right. So there is
right,
more confusion, and that
right.
is very tough for us also. Right, sir.
Okay. So all the best for your exam. I
Thank you,
hope
sir.
you all will get very good grades.
Thank
So
you,
my
sir.
wishes are with you. Okay. Okay. Thank you for joining all the sessions. I
Thank you,
hope
sir.
we will meet again. Okay,
Sure,
thank
sir.
you everyone.
Okay, thank you, sir.
Yeah, thank you. Very nice
Thank you.
session.
Thank you.
Thank you.